Have you ever wondered what makes up the fabric of reality itself? What if everything we know, everything we see, feel, and experience is but a symphony of tiny, vibrating strings? Welcome to the world of string theory. Picture the universe for a second, not as a collection of particles, but as a cosmic orchestra, each string playing its own unique note. This idea was born in the mind of a physicist, Gabriele Veneziano, in the late 1960s. While trying to explain the behavior of subatomic particles, Veneziano stumbled upon a mathematical formula that, unbeknownst to him, would lay the groundwork for string theory. But before we dive into the theory itself, it's important to understand our current framework of reality. Since the early 20th century, physicists have used quantum mechanics to describe the behavior of the smallest particles in the universe, while general relativity has been used to explain the behavior of the largest structures, like galaxies and black holes. Yet, there's a problem. Quantum mechanics and general relativity are like two languages that don't speak to each other. They describe the universe in fundamentally different ways. This is where string theory comes in, offering a potential bridge between these two conflicting views of the universe. In simple terms, string theory suggests that the universe is not made up of point-like particles, but instead, tiny one-dimensional strings. These strings vibrate at different frequencies, and it's these vibrations that give rise to the different particles we observe in the universe. In the world of string theory, there are no separate laws for large and small. Everything follows the same set of rules. It's a theory that dares to dream, to unify the laws of the universe under one banner. Now, it's important to note that string theory is still just that, a theory. It's a beautiful idea, but as of now, it lacks experimental evidence. Yet, it's a theory that refuses to be ignored. One of the most fascinating aspects of string theory is the idea of extra dimensions. According to string theory, there could be as many as 10 dimensions of space, not just the 3 we're familiar with. This is a concept that's difficult for us to grasp, living in our 3-dimensional world. Remember the story of Albert Einstein, who once quipped, when asked about his theory of relativity, "When a man sits with a pretty girl for an hour, it seems like a minute. But let him sit on a hot stove for a minute and it's longer than any hour. That's relativity." Well, the dimensions in string theory may be just as elusive and relative, hiding in plain sight, yet beyond our everyday perception. So, what have we learned today? String theory, with its vibrating strings and extra dimensions, offers a potential unifying theory for our universe. It's a bold vision, one that blends the micro and macro, the quantum and cosmological into a single harmonious symphony. But it's also a theory that's still in its infancy, a work in progress. It's a daring leap into the unknown, a leap that physicists like Veneziano and many others after him have been brave enough to take. And in the end, isn't that what science is all about? The courage to explore, to question, to dream. Whether string theory is the final answer, only time will tell. But one thing is for certain, the quest for understanding the fundamental nature of our universe continues, one string at a time.